Now let's look at an example. This is fairly lengthy, so let me uncover it line by line to help you copy it down. A total of $65,000. A total of $65,000 was invested. Part at 7.25% and the rest at 8.5% simple interest. Let me read that sentence again. A total of $65,000 was invested, part at 7.25% and the rest at 8.5% simple interest. The total annual interest income, on the investments was $5,025. The total annual interest income on the investments was $5,025. How much was invested at each rate? How much was invested at each rate? Notice that we have quite a few numbers in this problem. We have $65,000, 7.25%, 8.5%, $5,025, 4 different numbers. We need to organize this information so that we can tell what goes where. To organize information of this type, a chart is a big help. I'm going to work this problem using a chart, and I will tell you that problems like this can best be worked using a chart to organize the formula and the pieces of information that are given. As we go through the chart, it's not going to work for me to put this problem statement back up over and over again. So I'm going to rely on you to look at your own copy as we go through. If you have not yet got this copied down, pause the tape, rewind it, and get the problem copied down exactly right. It's going to be crucial that you have these numbers before you and all the words surrounding them. So let's go to our chart and write down the information that is given, the formula that we'll use, which is our interest formula, and the information about the two accounts. Here's the chart. The chart has, down the left-hand side, first account, second account, and total. First account, second account, and total. Why do we need a total? Well, we're told at the beginning a total of $65,000 was invested. Since this total comes from adding up things, I've put a double line across above the total mark that is a reminder of the equals mark. It's sort of like a great long equals mark, and that helps to tell where the equals mark will be in the equations that we'll come up with. Across the top we have our formula. P times R equals I. Principal times rate equals interest. I have divided up the chart to allow for numbers under the P, numbers for principal, numbers for rate, and numbers for interest. But I've kept the relationship P times R equals I across the top so I can tell how the pieces will be put together. Alright, let's take a look at the numbers now. Do you have your numbers handy? The first number we have is $65,000. A total of $65,000 was invested. What is that? Principal, rate, or interest? Well, that's what was invested, therefore it's the principal, and it is the total. So the $65,000 goes in the position of the principal in the total row. I'm going to leave the dollar mark off just to make it easier to write and less cluttered to look at. The next number I have is 7.25%. The rate is always a percent, but remember that we write the rate in decimal form, and so we convert 7.25% to 0.0725. The second account, 8.5%. 8.5% in decimal form is 0.085. The fourth number in my problem is 5,025. That says the total annual interest income on the investments was $5,025. Total annual interest income, and so the 5,025 goes in the last column at the bottom. All four numbers have found their positions in the chart. The only thing left is to fill in 1, 2, 3, 4, 5 more slots, either with a letter, a formula, or a blank. Well, the thing I'm supposed to find out is how much was invested at each rate. That is, I'm supposed to find the principal. So let's call the principal in the first account X. The principal in the second account must be a different letter. Let's use Y. It must be different because if I call both of them X, that means I'm certain that both of them are exactly the same amounts of money. But I don't know that, and so I cannot make them be that way at the beginning. If it works out that they're the same, that will show up at the end of the problem anyway. So I cannot assume at the beginning that they are the same unless I'm told so. I have X and Y in the principal column, and now I can use my formula. Principal times rate equals interest. X times this decimal 0.0725, and so I get decimal 0.0725x. The Y times its decimal percentage, 0.085y. And then at the bottom I have $65,000. I don't have a percentage rate, and the 5,025. Well, what do I do for the percent? Do I add the percents of the first account and the second account to get a percent for the total? Think about that. If we drop the decimals for a moment and say that the first one is 7% and the second one is 8%, if I put some money in an account at 7%, some more money at 8%, does that mean I'm going to get a total of 15%? No. I can't get more than the highest one on there. I cannot add these percents to get a number in this next column, and so I simply draw a blank to indicate that I meant to leave it blank, did not overlook something. Well, now we have two variables, X and Y, and so we're forced to have two equations. Our first equation comes from principal in the first account plus principal in the second account gives the total principal. And so our first equation is X plus Y equals 65,000. The next one comes from the interest column, the other place that I have both X and Y. So I add the two interest amounts, 0.0725x plus 0.085y equals 5,025. So here my pair of equations is, and I'm going to solve these equations by the addition method. Well, I have some lovely decimals here. Which letter shall we eliminate? Let's choose to eliminate y in this one. I'm going to eliminate y. That means I must multiply one or the other, rather I must multiply each equation by something that will eliminate the y term. I'm going to leave this bottom one as it is, multiplying it simply by 1. That means I'll multiply the top equation by the opposite of the coefficient in the bottom one, which is minus 0.085. So I multiply the top equation by minus 0.085